Okay, I'm going to start class now. I just pushed the record button, so hopefully that'll work. Let's see, I'll read. I can send a notice on Canvas, my phone, you think, huh? So you can get the Canvas app for your cell phone. That's interesting. Okay, I'll look into that. I don't know if I have time to do it right now. I feel really lucky because everything's gone very smoothly today. I was expecting it to be kind of a hard day with my poor router, but so far so good. Thank you, though. I'll look into that. That would be a good backup. I think spring break is next week, isn't it? Let me take a look and see. Let's see, 26, yeah. So I think it's next week. So hopefully that'll give me time to, since I'm obviously not going to be, going to Fort Lauderdale or anything, it'll give me time to switch to figure out, maybe improve my home network setup here. So let's see, today the first thing that I want to talk about is the homework assignment. It's coming up due in a couple of days. And let's take a look at, desktop's kind of a mess here. Let's take a look at that assignment for a moment. Let me get rid of a few things. I'll be right with you. Bring up my desktop a little bit. Okay. So I think you can see this screen. So let's over here to assignments, Jedi Zero. There he is. So, so this is like kind of a little bit of a warm up to Jedi, which is going to be our focus coming back from spring break. Jedi is an interpreted language, and it's similar in some ways to Scala interpreter. You type in expressions and they produce values as outputs here. So, 2 plus 3 times 5 is 17. We can just kind of go through this little sample session here. So I'm doing various arithmetic expressions. One cool thing that you see here is that if the inputs are all integers, then the answer is an integer. But if even one of them is a floating point number, the answer is floating point. I can define things. One improvement over Scala is that I don't like that Scala has val and var. So is there a question there? No. I'm sure that you're muted unless you have a question. There's just one way of defining things in Jedi, and that's using the word def. So here I'm defining the constant pi is okay. And if I say what's pi, it's 3.14. Here we're going to be going over this in detail after spring break, but here's how you define a function in Jedi. So again, it's just def square equals, and then here lambda is like kind of a keyword that you can think of lambda as saying make a function. And it wants to know what are the parameters for this function, and here's the body of the function. says, okay, and now I can call this function. Square of 7 is 49. Here's another function, area. It's a function, there's a parameter r for radius, and it's pi times square of r. And so now, what's the area of a circle of radius 10? Well, that's 314 units. We can do, here masking is pi less than 3 and is z less than 10. It says false. Notice that z is undefined. Why didn't it crash when I typed this in? Well, because of short circuit execution. Pi less than 3 is false, and whoops, that's all I need. If this is false, the whole thing's a false. He never looks at z is less than, he never looks at z is less than 10. Let's see, I'm getting some chatter going on here. How come I cannot ever see the chat window? I mean, sometimes I can see it, sometimes I can't see it. I mean, I know I can see it if I quit out of, if I stop the view. Maybe I should do that. Can the lambda take more than one argument? Yes, it can. They have to be comma separated. I just got to get better at doing this, don't I? Here, same thing. If pi is less than 3, then return x, else return 100. It returns 100, even though x is undefined. That's because right away, seeing this is another form of what's called lazy evaluation. As soon as you know the answer, you don't have to execute everything. So pi less than 3 is false, so I'm going to go right here to 100, skipping over x, which is a good thing because x turns out wasn't defined. Here's how we do variables in Jedi. Define count is a variable containing 0. And so when I print out what's count, it says, well, I'm a variable containing 0. If I put braces around count, it tells me the content of the variable. Here I am incrementing count by its content plus 1. So a lot of languages going back, I think we've talked about this a little bit in before, distinguish between the L value of a variable and the R value. The L value is the variable itself. When it appears on, L stands for the left-hand side of an assignment. And if it's on the right-hand side, then it's the content. Well, we don't do that in Jedi. If you say, what's count, you get that it's a variable. If you want to know what's inside the variable, you have to explicitly dereference it. Has a while statement in it. You can do right, so this is just like a little, teaser. Here is the design of this thing. So this is the design you're going to be using. So I've got 3 packages: value, expression, and context. And unfortunately, all of these packages are interdependent. These little arrows here means value depends on context, context depends on values, and so forth. That's like not a desirable design. You'd like to have just one-way arrows in here, but my arrows are, there's a lot of interdependence here. And so now we're going to go inside the expression package. And here, that won't, this is the problem. Lost my window altogether. Where did it go? Hang on a second. Stop sharing. Okay, there is everybody again. How can you allow extending with classes that are in different package? Well, you import right? That's the idea behind importing. All right, let me see if I can figure this out again. Okay, I just lost a window. It's hard, I think, to manage these. The chat window, the Zoom window, and then the window that I'm sharing. And I'm always like sort of desperately looking around, trying to find it. So here is the expression package. Here's like a little teaser of what's in there. So we have this expression trait, and every expression knows how to execute itself. When it executes itself, it needs as an input an environment. This is like a runtime environment. This is going to be a table. We need this because you can do things like you can say, well, what's pi times 2? Well, I need to know, in order to execute that, I need to know what pi is. So this environment is like a lookup table where I can look up the value of pi and say, oh, it's like 3.14, so now I can multiply it by 2. And this produces as this output a value. We've seen baby versions of this before. And then here we have literal is a trait, identifier. Identifier is going to be like a name. So identifier is a fancy word for name. So this is going to be, X, Y, Z, something, like that, or pi. Fun call would be something like that square function or the area function that we just saw, or when I called the square function, rather, when I called, square of 10. And then literal will be things like numbers and strings and Booleans and so forth. Here's the context package, isn't the complete thing. So right here we have the console. This is a singleton. And this is, it has the main in it, and it has read, execute, print loops. So this is the thing that prints the prompt. This is what's driving, it's the engine, which prints this little prompt, reads in the expression, executes the expression, asks the expression to execute itself, and then it prints out the value of that expression. So this is a fun call expression. So it prints the prompt, reads that expression, parses it, asks it to execute itself, and displays the answer. Here is there's this environment that we start with called the global environment. So it's sort of like the beginnings function table. Later on, we'll learn how to extend that. It also has a bunch of parsers over here, so we're going to talk about that a little bit later on. It depends on, so you can just ignore this dashed arrow. This is the dependency arrow. There's a hierarchy of different kinds of Jedi exceptions. Type exception is thrown for type errors, such as 3 plus false, for example. Right? Well, that doesn't make sense. That's a type error. It has to be 3 plus a number, not 3 plus a Boolean. Syntax exception. This is if I called square of 10 but forgot one of the parentheses. That's a syntax exception. Undefined exception. This happened, was thrown when I asked what's the value of X. Well, I hadn't gotten around to defining X yet. And then the other thing is that not everything can be defined by the programmer. You need some starting functions that are built-in functions. These are usually arithmetic and logic functions, and they live in this singleton object here called the ALU, arithmetic and logic unit. Here is the value package. In the value package, we have this value trait, just an empty trait. It's kind of a catch-all for all of the values. And here we have notifications, variables. You saw variables. Closure is just a fancy name for function. This is what gets made by Lambda. store where this is meant to be like a, this is meant to be a buffer or something, a list. This is my only collection class, but we're going to skip it. Notification are things like you see sometimes, like when you execute an expression, if it has a side effect, it just returns like okay or done, something like that. And then literals are expressions. So literal is both an expression and a value. And underneath it, we have bool, chars, integer, and real. And that's what we're going to be doing for Jedi Zero. So that's like kind of like an overview. And the thing that's most important for you to grasp right now is this dichotomy. We have expressions which can be executed. You can think of an expression as a kind of a query. What is 2 plus 3? Okay? And it produces a value over here, which might be like an integer or real or something. And there's an overlap between values and expressions, things that are both values and expressions, and those are called literals. You know, like I could just type in like a number, 23, to the interpreter's prompt, and essentially I'm asking the question, what is the value of 23? And of course, the answer is the value of 23 is 23. It's literally itself, which is where we get this literal from. So that's the, you know, that's the big picture here. So I am going to stop the share for a moment and try to find out what happened to this window. Don't know. All right. So that's the overview of Jedi. Here's a question coming in. Is literal in the expression package or in both express? You know, that's a good question. So Mike is asking, is literal in the expression package or both an expression and value package? It wouldn't go in both. I don't think that's possible to do. It would go in one or the other. And the way that I've decided to do this is I have literal in the expression package, but its extensions like chars, real, integer, they all live in the value package, although that could be done in different ways. Okay, so now let's go to Jedi Zero. So you're going to create a project called Jedi. Maybe we can do this together. Yeah, let's do it. Let's do it together, shall we? Maybe I'll give you a minute to, if you want to like do this with me. Maybe you've already done it. We had the 4 packages. I'm going to add another package called the test package. And then I'm going to put these other classes in here. So let's try that. Let's work on that together. So this is a new share. I'm going to go to Eclipse. Is this Eclipse? No, this is not Eclipse. Eclipse running. Maybe this is Eclipse. No. Just go away. Screen share. Let me try this again. Oh, this looks like this is Eclipse. Okay. All right. So I'm going to create a new Scala project. Okay, and my project will be called Jedi. is. Now expand that in source. Let's create a new package called value. Another package called expression. Package called context. Package called tests. Oh, test singular, test plural is better. So using the class diagram as a guide, define the expression, literal identifier, and value, notification, real integer. So we're going to put all of these things in their proper packages. Okay, so let's do that. So let's start with value. In here, I'm going to create a new Scala trait. Now here are the uppercase letter values. My packages begin with lowercase letters and uppercase letters for classes and traits. And this is it for value. Let me get rid of it. That's my value class. Let's go over to expression. And we're going to add to expression a Scala class called expression with an uppercase E. Okay, and oh, you know what? This is supposed to be a trait. Trait there, and that'll be fine. And it has in it now this thing's going crazy here. It says, oh, what is environment with value? So I have to import so that made it happy. But what about environment? Well, I think, go back and look at this code here for a second. So I give you environment here. So I'm going to, that's in the context package, new Scala class environment. Environment. Okay, so what is an environment? So we're going to change this. We're going to make this a little more detailed a little bit later on. But let's take a moment here. So here is like Hashmap, and that comes from, I guess it knows. I've already given the full qualified name of it. So remember, a hash map is a kind of map which associates identifiers with values. So an example of an identifier would be something like pi, and then the value would be the number 3.14. Now it doesn't know what a value is, so I'll import that. Okay, and it doesn't know what identifier is. So let's look at, I think I gave you identifier here. Here's the identifier class. Copy that, and that lives in the expression package. And it's, again, doesn't know what's, so let's talk a little bit about identifier. So An identifier is a fancy word in programming languages for name. So these are names that were introduced through def. So you saw, you know, oh, I'm not on the right. I'm sorry, I'm not sharing this with you. Okay, so here we are. So identifiers are names introduced by using def by the programmers, right? So, you know, when you saw me doing things like def pi, so these things, these guys here, def creates or introduces so all of these guys are introducing identifiers. And so inside of an identifier is the actual name as a string. So this name would be pi or square. Identifier is an expression. Okay, here is my two strings, so it'll just print out like the name. Okay, and what else? Oh, so important thing is that all of the classes that are in the expression hierarchy, not the value hierarchy, the expression hierarchy, are going to be case classes. Remember, case class, we introduced that last week, automatically introduces what a companion object with apply. You can use these things inside of match case. It'll like sort of disassemble it for you automatically. So more on that a little bit later. It's struggling with environment here. Let's import. Where is that context? Should expressions be a class? Well, first of all, it's expression singular, Abdurrahman, and it should be a trait. Oh, I see. You already got the answer here. All right, good. So now what I want you to do is just take a moment here. This guy won't hide, go away. Take a moment here to think about execute. Okay, so this execute is going to get called, like, here's the prompt, and I'm going to type in pi, and it returns 3.14. And so when I typed in pi, pi is an identifier, and this called this execute function. And somehow the answer was 3.14. And so I want you to take like, take a minute if you're working along with me and figure out what you would write or what you should write for these question marks here. Okay, remember env is a hash map, and it's going to have in it the identifier pi. Remember how you get the value from a hash map? You can call it like a function. And what's the identifier? Well, this is the identifier. That's it. That's the beauty of object-oriented development here, is that ordinarily execute for expression would be a long, complicated function. But when you do object-oriented programming, instead of one centralized gigantic execute function, it's decentralized. You know, we have execute for each of these expression subclasses, and it's very short. You know, and we're relying on polymorphism to, to figure out what code should be executed. Okay, and let's see. Picking up some error here. Oh, identifier. So we now have an identifier class. Let's save that. Let's go to the environment class and we will import there. Okay. So everybody seems happy. Here is this guy we're going to need to import. This is why all of those dashed lines in that package diagram are essentially import statements. And so I'm now paying the price of that complexity here by having to put in all of these imports. Let's see. Okay, now he's happy as well. Over here to value, he's happy now. Let's go back and look at the assignment. Okay, so then they want expression, got it, literal, we'll do that next. Identifier, value, notification, I'm gonna leave that off for a little bit, real integer, chars, bool. Let's do literal next. Okay, so so I put my literal in the expression package. Let's see, a match case expression. I think it's calling, I get not found identifier environment.scala. All right, let's check that out again. So here's my package structure, your package structure. We're going to be working on this for the entire rest of the semester, so you want to make sure you have it sorted out. So here is context as environment.scala. Make sure that your spelling is correct. Context is lower. All of the packages begin with lowercase, and environment begins with uppercase. Make sure everything is saved. I gave you this code. Value package just has trait value in it. Package value up here. And then the expression package, let's expand that. Expression is singular, uppercase E. It's a trait with this execute thing in it. And of course, here are all of these imports. Identifier is a case class. It's got a string inside of it. I think I gave you most of this code. And here it's env of this. So again, environment is a hash map. So you can call it like a function and it'll search the hash map. And the identifier, let's go back and look at environment one more time. It's a hash map. The keys, the search keys are identifiers. And the values are values. Literal is a trait. Oh, thank you. Okay. Yeah, somebody's just pointing that out. Let's see. So I screwed that up. It's like hard to like kind of work around. Hard to work around all of the Zoom menus that keep popping up. Okay, so now according to the class diagram, literal extends trait, extends expression. It also extends value, so we have to write with value here. We're going to import import value. We will import expression. Now, because it extends expression, you need execute. So, gosh, now we're going to need to, I don't need to, I'm in expression, so I don't need to import. I don't need that import. But I will need to import from context iron. I want you to take, I'm going to take a few minutes here, and I want you to figure out how to implement execute. Now you might be, remember the, this is screen that I'm sharing, yeah. Remember that, that the kinds of subclasses of literal are going to be things like real, integer, chars, and Boolean. Okay, but here's the interesting thing. I can implement execute here, so I don't have to implement it in those subclasses. So here's where this is going to get called. And so here's the prompt. If I type in 3, the answer is 3. If I type in true, Boolean, the answer is true. If I type in chars is a string. In other words, if it's a literal, so integer is a literal, Boolean is a literal, chars is a literal, and real is a literal, it just spits it right back at me. So given that, what should the return value of a literal be? So Mike is saying, would it just be equal to this? And that's exactly right. You're asking a literal, what is your value? I am my own value. Very good. Right, so now let's do integer, and I'm going to copy paste this code. I put integer in the value package. It's a class. It is really raining hard here. Probably have to import a bunch of stuff. I'm getting an error message down here because I haven't defined real yet. That's okay. I'll just comment this out for a moment. For some reason,
we can't see Eclipse.
Oh, thank you. Thank you.
Uh-huh.
There we go, right?
Thank you.
I was saying it really bothers me, to see like an error message in here. I mean, the error is that I haven't defined real yet. And so it's not, go away when I define real. But personally, it just sort of gnaws at me to see that little red bubble there. So I don't like it. So it turns out that integer, all of these literal subclasses need to be case classes also. So that's one thing. All right, and then this is class integer. Now, here is an important piece of this thing. I'm trying, what the whole Jedi project is that we are writing a specification for both the syntax and semantics, the structure and behavior of Jedi, and we're writing that in Scala, right? So it's a little bit like if, we were learning French, right? And French is the object language, and the meta language is English. And so I would be saying to you, bonjour in French. That means, good day in English, right? So I'm just translating the French into English. Here, I'm trying to explain to you what a Jedi integer is. Now, you're all expert Scala programmers by this time, so you know what a Scala int is. And so what I'm saying here is, an integer in Jedi, that's really the same as an int in Scala. And so the way that I do that is integer, Jedi integer is just a wrapper class for a Scala int. Okay, so every integer has a Scala, every Jedi integer has a Scala int inside. It extends literal. Okay, and then here the exercise is that I want you to, it's going to be ordered, and it's a value class, so it's going to have this equals here, which is kind of silly, but it implements the equals trait. Okay, so we can see down here, I've got my override of equals. Okay, if other isn't any here, some of you missed that on the midterm exam. So equals takes an any as an input. The other is of type integer. Now here, one of the beauties of case is that it automatically casts other as an integer here. So this can equal other is just other dot instance of integer. And I don't like this stupid can equal stuff. Well, I'll leave it as it is for now. And then here is the important part. Okay. Other dot value is the same as this dot value. So two Jedi, so what this is saying here philosophically is that two Jedi integers are equal in case the corresponding Scala integers are equal. Okay. Compares with another Jedi integer. And this has to return a Scala int because that's the way ordered works, right? So if this dot value is less than other dot value, if they're the Scala integers are like this, I return -1, else if it's bigger, I return 1, else I return 0. So that's just the way that compare has to work. If you say you're going to implement this ordered interface, then basically you're saying your overriding can equal, I'm sorry, you're overriding this, you're not overriding, you're implementing this compare method, which returns an int. And then up here, let's look at plus. So this is something I didn't quite get to when we were talking about object-oriented programming, but it's this cool feature. Object-oriented programming, you can define infix operators for yourself, plus, times, minus, divides. So here, this is how do you add yourself to another Jedi integer? Well, so, you know, again, like think about the French class here. I'm asking you, do you know what plus means in Scala? And you say, well, yes, we do. We're all expert Scala programmers. Okay, so if I add this plus other, what I do is I add this is Scala Addition here, and these are the Scala ints that are inside them. I'm going to add those together, and then I'm going to store the result back inside of a Jedi integer. Okay, so this is essentially saying, what this is saying is that integer addition in Jedi is pretty much the same as integer addition in Scala. Okay, but you have to extract out the Scala values, add them together, and then wrap them back up again as a Jedi integer. So we would copy this. So I'll do it for you. You could just copy this for all of the rest of them. Right, here's times. See, already those error messages are bothering me. Times, minus, divide. And then what about, I mean, you can also have, there are two minus operations. There's binary subtraction, A minus B. There's also negation. Well, negation, the name of that operator is unary underscore minus, unary negation. And so this is going to be an integer. Notice I don't have to say new here, of negation of this dot value. Okay, so there it is. You're going to do the same thing. You're going to copy paste this class, and you'll change its name to real. And everywhere you see integer, you'll change that to real, and it should be pretty much the same thing. Let's look at number test here. So this is number test 1. So I'll get this number test 1. Okay. Let's go back to so I'm going to go to the tests package. I'm going to add a new, was it an app? I have to go look and see. Yeah, it's an app. I'm going to add in number tests a new app, Scala app. Paste this in. Okay, so this is a little app to test to see if things are working. And I'm going to have to comment out part of this stuff. Okay, so now Let's see, can I maybe run this? Be asking too much? Yeah, okay. So I think those are probably the right answers. But check out this code. So here I'm creating two Jedi integers, I1 and I2. I1 is, and again, you don't need new here because integer is a case class. So integer 7, integer 6, and now check this out. Here is infix multiplication, I1 times I2. That's calling that star operator. This is calling the equals operator. This is calling the compare to operator. And then this is calling the hash code function. Okay, so it's kind of cool, you know, in most programming languages, infix operators like plus and times are only used for the built-in types. So you lowly programmers aren't allowed to attach your own definitions to the infix operator. Only the language designer can do that. But Scala says no. You know, plus and times are just like any other identifier. You can define them just as you please. Okay, so you're going to create in the value class, you'll create real.scala. And real.scala will, I think, be pretty similar to this. And with just real put in. And then you can come back and uncomment this guy. I think it'll just be frightening if I try to explain what's going on with this implicit def right now. So I'm going to hold off on that for a little bit. What else needs to be said here? Chars class. So chars, I decided to be too confusing if I use the word, if I had a string type in Jedi. Instead, I've got like a chars type, and chars, a chars encapsulates a Jedi, a Scala string, right? So, you know, sort of look sort of like this. Case class. Let me just do it over here. It's too small and weird there. All right, so here I would put in class. And this is going to extends literal. And probably you're probably going to want to do going to be ordered. You're going to need all of these for all of these guys because they're all value classes. Okay. And then you will also have, don't put it in the same file here. I'll do it this way. I call mine bool rather than Boolean. Just to just because it gets kind of confusing. So much copying of code that I do. That's the sign of a really lazy programmer. And in my book, a lazy programmer is a good programmer. Okay, so why is it not liking the word bool here? Oh, because I haven't implemented some of these methods. I don't think bools need to be ordered. Right, so basically, a Jedi bool is just a wrapper for a Scala Boolean, is what this says. Right, and here are tests for all of these things. So all of these tests should run. Expression tests. Now here's expression test. Here I'm going to create a new environment. I'm creating pi as an identifier, num is a real, and then I'm putting pi is associated with the number 3.14, and I'm going to execute pi in the global environment. I can execute num in the global environment. So this is just, testing out like the global environment. And I think that's it. Oh, yeah, because you'll want to know about this. Notification. I guess I should say a few words about that. Okay. So the policy, our policy in Jedi is this, that if an expression has a side effect, produces a side effect, then it does not produce a usable value. It just produces like some kind of an acknowledgement that the side effect happened. Okay, so I don't like hybrid expressions. A hybrid expression is one that produces a value and a side effect. So we've talked about this before in class. We don't like both of these things. I'm getting a bunch of questions on chat. I better take a look at this. Where is integer located? Yes, value package. Thank you, Brianna. You can see who puts it in package explorer. Yeah, okay. I think you guys are not panicking too much. That's good. So if you are a side effects, who's done in the unary line? Well, I'll show you that later. Sharp, by the way, so I'm just, showing off. Sharp is hash code, is like an abbreviation for hash code that Scala uses. So it's the same as I1.hashcode. And there, unary, there's two net minuses. There's binary minus, A minus B, and unary minus, which is just negative A. And binary minus is just the minus sign, and unary minus is unary underscore minus. Once I have that, I can do, -3, for example, in Jedi. The point of all of this, by the way, is to make your Jedi value classes look just like the the corresponding classes in Scala. There's also unary negation. Somebody's writing negation, I guess. Let me show you that real quickly. Here I started bool. think it's this. This is the definition of reading the bool package. Yes. Let's see if it likes it. Well, it's not complaining. So this is unary not, right? And so I extract out the Scala value. This is Scala not. And then I wrap it back up as a Jedi bool. So it's always, all of these things are unwrap, get out the Jedi value inside, combine it with whatever operator, the corresponding Jedi operator, and then wrap it back up as, I'm sorry, let me say it again. All of these operations, let's define, does that work? Think about what this is going to be. You're going to extract out, there's this dot value and other dot value. Those are the Jedi, those are the Scala values. That's Scala and, right? And then you're going to wrap it back up as a Jedi bool. So unwrapping, that's the this dot value, combining in Scala, and then rewrapping it back up as. Okay, so notification. This is going to go in value class. So notification is a value. It's just not a very interesting value, purposely so. Let's see, what do I call this? Name for now. Okay, so side effects. When do side effects happen? Well, right now, I think the only thing that we do that has side effects are when we use def. Remember, that has the side effect of this updates the environment. We haven't done def yet. It's a special form declaration. As we get to that in Jedi 1, that updates the environment. So it's put in the environment. You know, basically it does this. Right, so it sticks a new row in the environment. So that is something that you don't get to see. And then, you know, this is type this in at the interpreter's prompt. And then the value returned is just okay. In other words, I don't want my programmers, I don't want my users to somehow use, like if this returned 3.14, like in some languages, then they could do some crazy thing like 3 plus def. You know, C programmers love this kind of stuff, right? But I think that this is like leads to code that's very hard to maintain. So in order to discourage this, I'm just returning okay. Now I promise, now defining a definition is an expression, and I promise that expressions always return values. So I have this special notification class that you know returns. We can override toString here so that it produces just the name, and then we could have like a companion class. right? And in the companion class, we could define, you know, some commonly used notifications like OK. Right? Another notification would be done. Another notification might be unspecified. So these are commonly used notifications that for different kinds of expressions will come into contact with. Yeah, okay, done and unspecified. Okay, so that'll be our policy. So hopefully you've followed along here. What do we got? Notification be a case class? No, I didn't make it a case class, but I would provide a companion object where I will have an apply method in there. But no, it doesn't need to be a case class. Just expression classes need to be case classes. Okay. So Mike is asking, aside from toString, yeah, the only thing that I would add is in my companion object, I'll have like the usual apply method, so you don't need to use new all of the time. This is in the notification class. Yeah, that's it. Pretty simple. All of these classes are simple. There's no complicated code in here. What there is lots of classes. So you have to know like how all of the classes hang together, you know, what package they're in, what hierarchy they're part of. But the actual code in the class is all fairly simple. All right, let's step away from this for a bit. So that's Jedi Zero. So this is just like kind of the foundations, the starting point that we'll need. And then my plan is that you know, Jedi 1.0 will just add to this. All of these different Jedis are just going to add to the project that we've already started. So we're just going to be teasing this project along. We'll probably get up to Jedi 3. I don't know if we'll get up to Jedi 4 or not. Okay. Let's see. So I only have 5 minutes left. Let me just tell you what I'm not going to do. Let's see. Oh, so Christy's asking, why can real multiply with integer, but not vice versa? Well, I mean, here's the idea. If you multiply two integers together, Christy, the answer should be an integer. That's just integer multiplication. If you multiply two reals together, the answer should be a real. That'll be real multiplication. But then there's this special case, like if you multiply a real times an integer or an integer times a real, like 3 times 3.0, then the answer should be a real. And what has to happen there is that do I still have the Jedi code here? The trick for doing that is in this line here. So this is a really cool feature of Scala. And basically what this says is if an integer is used in a context where a real was expected, for example, multiplying 3 times 3.0, then we're going to convert the Jedi integer into a Jedi real. So if you do 3 times 3.0, this method will be automatically invoked to convert the 3 into 3.0 to give you, now you're just doing 3.0 times 3.0, which is 9.0. And it's the same if you're doing integer or anything else. Okay, I'll say more about that like on Thursday, I guess. So we had been talking about regular expressions, and remember that in Scala, and I had these regular expression labs. And so my plan, maybe we'll do it on Thursday. I made an assignment, which is due at 5 o'clock, for you to do number 4 in these labs, and for you to do number 6 in the labs, and so that is on the assignments page, regular expression lab. So we will scrap that for today, and maybe that'll be an in-class lab that we will do on Thursday. And then on Thursday, we'll start getting into parsing. So you need to do parsing. And when they type in these, your users type in these complicated expressions at the prompt, then those things need to be parsed. Like if I type in something like, if I type in like the number 3.1, that has to be parsed into the Jedi real number 3.1. I mean, it's a string, and that has to be converted into an instance of Jedi's real class. So that's the work of the parser. And so once we have that then in place in Jedi 1, will be easy to implement. Right. Okay. I think that's probably enough of a mind dump for everybody. Questions? Oh, it's 4:15. Good grief. Okay, well, if there are no questions, I will end the meeting, and I will connect with everybody on Thursday. Nothing? Okay. Everybody stay healthy out there. Stay home. And I will be here again on Thursday. Bye.